Here we're looking at the isosceles triangle construction, the congruent angle construction or copy angle, and my personal favorite, the perpendicular bisector. So for an isosceles triangle construction, what we're going to use is the idea of equidistance. Every point on the circle is the same distance on the edge from the center. So every point on the edge out here is equidistant from that point. So that means that all radii on a given circle are congruent. So this segment's congruent to that segment. So you can make an isosceles triangle by drawing a circle and connecting any 2 points on that circle. So you put 2 points on the edge, automatically an isosceles triangle. Now the copy angle construction does use an isosceles triangle construction. So it helps to see the shape in the construction. So here you go, you see A, B, C. The angle, see these dashed lines? Those were not on my angle before. It just had this solid line and this solid line. None of this other stuff was here. So the first thing I'm going to do is I'm actually going to set up a baseline here to build my angle. And I'm going to try and make the same isosceles triangle. See A, B, C, and I'm going to try and make A prime, B prime, C prime. Well, all I have to do is set my radius to any point here and then use the same radius setting. So the compass point or center goes on A, mark it where I want it, move the compass center point to A prime, and mark it where I want it. So those will be congruent, and that'll be congruent. Now you're probably going, wait a second, won't that one be congruent? I haven't drawn that line yet. I don't know that that point C prime is right there. I know it's somewhere on this arc, so I need to make sure it's the same size for my isosceles triangle, and that's where this arc comes into play. I move my compass center to point B, and I'm making a circle around point B. So that it intersects. So I slide the radius indicator so it intersects with this arc and the angle line there, the ray. So once I set my compass mark and I make this beautiful mark here, I bring my compass point and put it on top of B prime and make the same kind of mark. Where these two arcs intersect, that's my point, and then I draw the straight line. So how do you know where to place point C? By centering at B and using the radius to reach C, and then doing the same thing on the other copy. There you go. We'll get some practice in class, and I'll show you doing some of the angles, how to copy them. We'll do some examples. All right, now the perpendicular bisector construction is my personal favorite, and it's perpendicular bisectors are very interesting lines. They are perpendicular to a segment, and they pass right through the midpoint. So this is a perpendicular bisector here without any construction marks. So it's just given as a perpendicular bisector. Again, there's the midpoint, and there's a right angle, and because it's a midpoint, both of these segments are congruent. So that's important to know. So what we're going to do is we're going to take a look at a line that I tell you is perpendicular and goes through the midpoint. What's interesting about that? Well, first of all, we're going to mark a point C anywhere on the bisector. I don't care where you put it. Then I'm going to tell you that AM is X and the distance from M to C is Y. So we're going to look at the lengths of AC and BC. So hopefully you'll notice that that's a right angle. If that's a right angle, that's a right angle. This is a straight line, right? So these are right triangles. So I can use, and I'm going to put my X there because both of these are congruent. I'm going to use Pythagorean theorem. This leg squared plus that leg squared equals the hypotenuse squared. So x squared plus y squared is AC squared. AC is the symbol for the length of the segments, since I don't have a bar on top. And I can solve for AC by just taking the square root. Do not worry that you're not getting a number right now. I'm just trying to see what this relationship is with these two legs. Okay, so I'm going to do the same thing with the other triangle. X squared plus y squared equals BC squared. And I know this is X because these are two congruent segments, bisectors cut in half. This is Y because it's the same segment as for the other triangle. And when I take the square root, I get x squared plus y squared. The square root of that is BC, which means that these two segments here are congruent. So what does that imply? If this is going to be the same length as that, that means any point on this perpendicular bisector, doesn't matter where it is, it could be here, 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 it will be equidistant from the endpoints of the segment it bisects. This will be congruent to that. Okay, this is the perpendicular bisector app, which I need to put on the website. Anyways, this is a perpendicular bisector. We just learned that any point on a line that bisects a segment and is perpendicular to it is equidistant from the endpoints. Well, equidistant should make you think of circles. So this point C sets my compass. Now you notice when I set my compass too small where it's not reaching halfway, this is another similar compass setting, then I don't really see my bisector. But as I make my points, my compass larger and larger, then you can see that both circles will intersect. Here's point D and point E. And because this radius is congruent to that radius, this distance is the same, that distance is the same. This distance is the same, that distance is the same. So this second circle, the radius is set for the compass, so it's the same as that circle. On a beautiful perpendicular bisector construction, you don't really have to do the whole circle, but there's no harm in doing it. And it's only where the circles intersect, right there and there, that's where your perpendicular bisector goes. These will automatically be 90-degree angles. So we know that a line is a perpendicular bisector because the points on the line are equidistant from the endpoints of the segment A. So for further reflection, what strategy is used to construct the perpendicular bisector? And we basically use circles to find equidistant points. And we know that those equidistant points will be on the perpendicular bisector. So wherever they intersect, that's how we construct it.